All right, guys, here's a video on the practice quiz sections 5.3 to 5.4. Let's begin with question number 1. It says classify the following polynomial. We should know that the first name is based on the degree, and the degree, the highest exponent, happens to be 4, so that would be quartic. And the second name is based on the number of terms, and there are 1, 2, 3 terms, so that should be a quartic trinomial. Quartic trinomial. In case you forgot, it's from this page of our notes from last week. The first name is based on the degree, first name, and the last name is based on the number of terms, last. So your degree is the highest exponent. If your highest exponent is 3, it's cubic. Highest exponent is 4, it's quartic. So in this case it was quartic, and there was 3 terms, which makes it a trinomial. So I would go back and study these notes if you struggled with this question. Number 2 is ridiculously easy. It says state the degree. The degree is the highest exponent you see. This is not in standard form, so the degree must be 5. So the correct answer is 5. Moving on to number 3. State the constant. Once again, this is not in standard form, it's out of order. If you wanted to rewrite it in standard form, you would have the 2x to the third first, and then the negative 7x, and then the minus 4. And now that it's in standard form, you could see your constant right here. Constant. Constant is always the number without the variable. It always stays the same. Another question asking for the leading coefficient. Once again, it's not in order. You have to put it in order in standard form, highest exponent down to smallest, down to the constant at the very end, which would require you to switch the first 2 terms. And now that it's in standard form, you could identify your leading coefficient. Your leading coefficient is -4. Notice that the negative in front of the 4 came with it when I switched it with the 9x squared. So the leading coefficient is -4, not +4. Moving on. Number 5, they want us to find f of -2 when f of x equals that, -2x to the third plus 8x. So we could do that by simply plugging in the value of -2. So let's rewrite the f of x function, but instead of x, we're going to put parentheses. And I put those parentheses because I am going to actually replace the x. Now with parentheses, I want to plug in that -2 right into those parentheses. I take that -2 and plug it in right there and right there. And now we do the math. What do we do first according to the correct order of operations? Do we multiply first? Do we do exponents? Do we add? Of course, we're going to be doing exponents. So what is -2 times -2 times -2? That is -8. So I still need to bring down this multiplication of 2, so put times -2, sorry, not 2, it's -2. And we also have the plus 8 times -2 over here. So what do I have here? I have -2 times -8, and I also have 8 times -2. So -2 times -8, that's +16. And over here, a +8 times a -2 is -16. So what we have here is 16 take away 16, which is 0. So on this one, you actually have to type in the number 0, hit enter, and that'll be the correct answer for number 5. This next question, number 6, as you could see, it's still a function notation problem, but this time we have to plug in not just a regular number, but we actually have to plug in a linear binomial into this x position and that x position. So this is going to take a lot of work, a lot of time. It's probably one of the longest, it is the longest question on this quiz. Let's first rewrite it with parentheses instead of x's. Once again, all I did was replace the x's, these x's, I replaced them with these parentheses. And now I'm actually going to plug in the a plus 3 right into those parentheses. And now that I plugged in the a plus 3, now I need to do the correct order of operations. We will begin with exponents, even before multiplying by 3 or even before subtracting 5 and all that other good stuff. So let's do that binomial, a plus 3 times itself. That's what squared actually means, to multiply it with itself. So when I distribute, a times a is a squared, a times 3 is 3a. Positive 3 times a is positive 3a. Positive 3 times 3 is positive 9. And of course, we're going to combine the middle terms, giving us a positive 6a. 3 plus 3 is 6. Bring down the a square in the front. Bring down the plus 9 at the end. And we need to understand this, that all I've done so far is the a plus 3 squared. This is the answer to a plus 3 squared. So I still need to multiply the answer by 3. So this is an answer. I need to multiply this entire answer, put in parentheses, by 3. So when you distribute that 3 times a squared is 3a squared. 3 times 6a is 18a. 3 times 9 is 27. Now what do I have over here? I still have the minus 5 that I need to multiply by a, and that'll give me a negative 5a. I need to also take that minus 5 and multiply by positive 3, giving me a negative 15. And again, I wrote that negative 15 down there. So what do I have left? I need to combine my like terms. So the 3a, this 3a, you can't combine it with anything, so just bring it down as part of your answer, 3a squared. And then we can move on to our a values. I have a positive 18a right here and a negative 5a over here. That will be positive 13a. And last but not least, we have 27 take away 15. That is positive 12. So there's my answer, 3a squared plus 13a plus 12. There it is. Yep, this one was long. On this question, they give us a graph of a polynomial function, and they give us possible true statements. We need to select all the true statements. The degree must be odd. Well, we know that's false because the end behavior has 2 arrows going down. That's an even amount of arrows. The number 2 is even, so it cannot be odd. So this is definitely not one of your answers. Now, end behavior notation, what this simply means, it tells you as x approaches positive infinity, f of x approaches positive infinity. So as x, where your x, here's your x axis. As x approaches positive infinity, does it go up or does it go down? As x approaches positive infinity, f of x does not go positive infinity the way this says. That's incorrect. F of x is the same thing as y. So as x approaches positive infinity, your f of x should go to negative infinity. So this one cannot be it either. Okay, cannot be it either. Now, if this confuses you, right, we're used to reading about x first before y. So if you want, look at the x part. It says x approaching positive infinity, going that way. Your y values are going to negative infinity. Yes, that is true, right? So this is definitely a true statement. If you're confused about the f of x being first before the x, go ahead and just do the x first and then see if it works with that y that they tell you, which it does. So this is one of the correct answers so far. Let's see if anything else works. It says a leading coefficient must be negative. Absolutely. We know it's an even degree function. If the leading coefficient were positive, it would have end behavior in quadrant 2 and quadrant 1. But as you can see, it got reflected to the other side of the x-axis, end behavior down here in quadrant 3 and quadrant 4. So that leading coefficient must be negative. So that's another true statement right there. Last but not least, it says it has 5 real zeros. Does it actually, to be able to answer this, you need to know what a real zero is. A real zero is a real answer. A real answer is an x-intercept. And as you can see, we have 1 x-intercept, 2, 3, 4. We do not have 5 x-intercepts. So we do not have 5 real zeros. Only 4 real zeros in this case. Moving on. If we read this first one, says select all true statements. The degree of this function could be 7. Now it doesn't say at least 7. It says it could be 7. And what we could tell is the directions that the graph goes tells us the least degree possible. So it's going down, that's 1, up 2, down 3, up 4, down 5. So we know that it has to be at least the degree 5, but that means that it could be 7. So yes, this is a true statement. You would select that one. Select that one right there, okay? The next one, the leading coefficient must be negative. Well, we know it's odd because it has an odd arrow pointing up and an odd arrow pointing down. But normally an odd function is down here and up here, right? Like y equals x. You see, I just drew the line y equals x. That's an odd degree function, and it has its end behavior in quadrant 1 and quadrant 3. So we know any odd degree function that has a leading coefficient that's positive is going to have it in quadrant 1 and quadrant 3. But this time it got flipped. So you must have a negative leading coefficient. So this one is correct as well. The leading coefficient must be negative. It says it has 3 real zeros. Let's check. Crosses once, twice, 3 times. That one's also true. Let's continue. As x approaches positive infinity, as you go to the right, does your f of x go down to negative infinity? And yes, it does. F of x or your y values is going down. So this is also correct. Okay. Again, x, that just means x-axis. Positive infinity is to the right, negative infinity is to the left. F of x are your y values. F of x to positive infinity is up, f of x to negative infinity is down. So right here it says f of x going to positive infinity. Your y value is going to positive infinity. That means really going up. So as you're going up, where are your x values going? They're going to the left. The x values are going to the left, right? Now, if you're confused because we're used to seeing x before y, go ahead and switch these and think about this x term first. As x approaches negative infinity, as x approaches negative infinity, right here, that's going to the left. Your y values go to positive infinity. That goes up. So that's definitely a true statement there. So those 4, actually all of these are correct. Every single one of these are correct. So check all of them and submit your answer. This next question says select the following true statements. Again, the degree of this function could be 5. Let's see. 1, 2, 3, 4, 5, 6. Nope. The least degree possible is 6. And it's an even degree because it has an even amount of arrows pointing up. So it cannot be 5. So don't pick that one. The leading coefficient must be negative. That's false also because a parabola that has a leading coefficient that's positive has end behavior in quadrant 2 and quadrant 1, right? A parabola opens up like that. So if your leading coefficient's positive, it opens up. If it has to be negative, that means it would open down. So your end behavior would be down here and down here, if that were true. But it's opening up, so definitely leading coefficient is not negative. There are 6 real zeros to this function. That is false. There are no real zeros. This blue graph never even touches the x-axis. Man, so far everything's wrong. The range is y equals all real numbers. Range are your up and down values. Does this go up forever? Yes. Does it go down forever? No, it doesn't. So it's definitely y. It doesn't equal y equals all real numbers. So that's incorrect also. Man. So the only one that's true is that none of these are true. So right here on number 10, it's a very interesting one because you could do it a couple of different ways. We know function notation f of negative 2. That means to plug in negative 2 wherever your x is at. So you could put parentheses, 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 and plug in that negative 2. That's one way of doing it. Let me show you that way. So I just rewrote it, but instead of x's, I put parentheses, as you could see. And I will be substituting the negative 2 right into those parentheses. Negative 2, negative 2, negative 2. Now, doing the correct order of operations, you're going to begin with parentheses, but there's nothing to do inside of the parentheses, so you could move on to e exponents. So when you do negative 2 to the 4th power, negative 2 times negative 2 is 4, times negative 2 is negative 8, times negative 2 is positive 16, and of course you could use a calculator. Now, over here on this next term, you're going to do exponents before multiplying, so you have to do negative 2 to the 3rd power. That really is a negative 8. So what you really have on the second term is negative 3 times negative 8. And negative 3 times negative 8 is positive 24, so plus 24. So far we have 16 plus 24. But let's do the other multiplications before we add or subtract. So we do have over here positive 5 times negative 2. That is a negative 10. And let's bring down the minus 6. And now let's add and subtract everything that we have here. 16 plus 24 is 40. 40 take away 10 is 30. 30 take away 6 is 24. So on this one, you're going to type in the number 24, hit enter, and that'll be the correct answer. That's one way of doing it. Another way of doing it is to use, and I haven't explained this before, but you might like it better than actually plugging in with parentheses. Whenever they tell you to evaluate, you could technically use synthetic substitution, which is almost identical to synthetic division. You guys remember synthetic division? Where we had a box, right? And if we were dividing by x plus 2, we would actually plug in a minus 2 right here. But right here, we're not dividing. We are plugging in a negative 2. So since we're not dividing, we're just plugging in a negative 2. Actually write that negative 2 right in that box, okay? And then you want to write the coefficients of all your terms representing every single power from the highest power down to the constant, right? So power 4, the coefficient is 1. So you would write a 1 right there. The next one, power 3, the coefficient's negative 3. So you'd write a negative 3. The next one's x squared. There is no x squared, so you'd have to represent that spot with the 0. You have the power of 1, so you could put that coefficient of 5 and the constant negative 6 at the very end. And we're going to do the same exact process as synthetic division. The only difference is whatever we get over here will be the output to the input negative 2. I know you've never seen this. If you want to stick with the original way of evaluating, plug in your negative 2 with parentheses, do all that math and get 24. That's great. Just want to show you some alternative options that might be easier for you. So the 1, you combine it with nothing because there's no number there, and you bring down that 1. And then you multiply negative 2 times 1. That'll give you a negative 2. And then you combine negative 3 and negative 2 is negative 5. And then you multiply negative 2 times negative 5 is positive 10. And then 0 plus 10 is 10. And then negative 2 times 10 is negative 20. And when you combine 5 and negative 20, you get negative 15. And when you multiply negative 2 times negative 15, you get positive 30. And then negative 6 and 30 combined is positive 24. And this is your output for the input negative 2. Same output, 24, 24. Was that easier? I don't know. It's up to you. Whatever you want to do. I just wanted to show you both ways.